Okay, so the very next video on the channel here is going to be coming from the same monitor haul of the previous video with the K7000 from hell. And I think we're in for a world of hurt on this one because this is a K7500, and I'm pretty sure we're going to have to call this one the K7500 from hell also. So you can see here, Wills Gardner monitors, 27-inch K7500. So this one was also left for dead in the same location as the K7000 from hell in the previous video. You can see this one's covered in foliage and leaves and dirt and grime and all kinds of stuff, just like the 7000 in the previous video. And for some reason there is an extra width transistor mounted upside down on the heatsink because there's another one right there. So that's kind of an oddity. But we've got dirt and leaves and grime and everything all over this one, just like the last one. And the ring here around the yoke is all rusted. The convergence ring assembly is just free floating here in the breeze, so I have to figure out where to put that back and get that resecured. And just, yeah, leaves and foliage and everything else all over this thing. But it is complete, and there's no missing parts. I did give it a visual inspection. Everything appears to be intact. So out of sheer morbid curiosity, I went ahead and turned it on, and something caught fire or exploded. That's just going to be how it was. But it did actually turn on. But the reason I think this is going to be the repair from hell as well, for the 7500 repair from hell, is because after I turned it on, here we go, 1, 2, 3, I am greeted with, let's see here, I still got a dirty lens, but dun dun dun, vertical collapse. So, zoop, collapse. So, the good news is it does work and operate, but we have collapse. Now, troubleshooting vertical collapse should not be that difficult on these chassis. It's a very few amount of components. There is a test point. Actually, I don't think these have the test point. That's the H-sync pin. The test point for the 26 volt reference, I think, is over yonder here somewhere. But there's a test point for the 26 volt reference. If we have 26 volts AC, no, DC, I'm sorry. 26 volts DC. If we have 26 volts DC at the test point, then we know all of our components and the vertical circuit from the flyback all the way to the vertical IC is good, and it's likely a bad vertical IC. If we don't have our 26 volt reference, then we know there's a component in the circuit that has failed or is faulty. But we'll go over all that stuff here shortly. But I wanted to show that this is likely going to be another repair from hell type of situation, because there is just all this junk and leaves and crap all over this thing. So the good news is it does turn on and operate, but it needs a good cleaning, just like the K7000 in the last video. So I'm not really too worried about this surface rust. This is just all surface rust. That's not a big deal. I mean, it's not going to get really any worse than that. Once it's removed from the exposure to the humidity and the elements of wherever it was stored, this is not really going to get that much worse. So I'm not really too worried about this. It's not uncommon for this to happen. As long as everything else on the chassis is clean and secure, and the yoke itself is in good shape, then I think we'll be fine. So I'm going to get this off the tube here now that we know that it works but just has collapse, and we'll get it on the bench and we'll go on the overhead and we'll go through how dirty it is and then clean it up just like we did in the video previous to this one on the K7000 from hell, and we'll see, hopefully this one doesn't give us as many problems. So before I go wash this thing, I was just going to go ahead and wash it and show it done to try and, you know, make sure we don't have another almost 2-hour video if this is another chassis from hell repair type of thing. But I figured, well, no, I'll go ahead and show it here. I've got it all disconnected, ready for washing. And again, I just clean this in the sink with some hot water, simple green, and a brush to agitate all the dirt and grime and rinse it off, compressed air, all the water off, and then come back and start working on it. So it's a pretty simple process. I just wanted to kind of show some of how bad this is here before we go and wash it, because I want to get a nice good a before thing, then we'll do an after. So I already kind of went through with the needle nose and picked up all the big leaves and chunks of dirt and stuff, but yeah, it's this one's particularly bad. I mean, I've seen worse, but it's pretty bad. So this was left in the garage, just exposed to the elements, you know, wind and rain and stuff, and water and moisture blowing in, things like that. So, all right, let's go get this cleaned and come back and see how it looks afterward. The neck board doesn't need washing because it's pretty clean on its own, so I don't need to wash that. That's good. Remote board is in good shape as well. So we're just going to clean and wash this main board, and as I'm looking at it here, I realize I forgot to, there's one more little leaf down here I want to grab right here, and it disintegrated as I tried to remove it, but there we go. So, yep, just spent a few minutes getting all that stuff out of here. So, all right, let's go clean this thing up. I'll come back and we'll see how it looks afterwards. So let's see if we can get this in frame here. There we go. And let's go clean it and come back and see how it looks after. So here's the before and here's the after. Squeaky clean. So, you know, not 100% perfect, but yep, pretty good. We do have a little bit of rust on the horizontal hold pot. Might go ahead and just replace that. I've got parts, so probably just replace that. But everything else, yeah, turned out really nice. So a marked improvement. Our sub-contrast pot's a little rusted as well. Might have to change that out. I do have that on hand also. Some of you more eagle-eyed viewers may have already spotted our vertical collapse problem, and we'll get to that here shortly. I'll show it, but yep, cleaned up very nice. Still a little bit dirty in here and over here, but it's hard to get the brush down in there to agitate all that dirt. I'm not really too worried about these being a bit rusted. As long as the resistor reads within spec, not going to worry too much about that. But as you can see, squeaky clean now, give or take. So very simple process, good to go. So what we need to do now is figure out why we have vertical collapse. And the vertical collapse is most likely caused by its hiding. Dun dun dun. Look at that. I'll bet you that resistor is wide open. Why that's wide open, I don't know. Couldn't tell you why that has burned up, but trying to see what resistor that is. Can't quite tell. I don't have that number memorized, so let's see if we can clean that a bit. See what it says. R402. So that is burned up. So what we need to do is measure it and find out what it reads in circuit. Let's just turn, there we go. We'll read it out in the circuit, see what it reads. I bet it's just wide open. Then we'll take it out of circuit, read it out of circuit, and then replace it, and then go through and get everything else done and try it out and see what it reads. So let's grab the meter and read it and see what it shows. So we'll grab the meter and zoom out here a bit. And in circuit, the resistor reads well, it's not open. 500K or so. It's not open. I wonder who wrote the book of love. Do I have? Okay, I've got a K7500 here, which is the same thing here for testing purposes. And let's see what it reads on the 7400 here. And yeah, 4 ohms. So we have a bad, what is that, R402? Yeah. That is probably going to be the source of our vertical collapse, almost assuredly. 4 ohms versus what was it, 530 ohms. Oh, now it's reading in the mega ohm. Okay, that's more of a reading I'd expect to see. Yeah, there we go, 3 mega ohm. So something must have been up with my connection, but yeah, that's more of what I would expect it to read. So if we set the 7400 back aside here, and extract our R402, which is right here, he says, with a question mark. Will I be able to do this successfully? I don't know. Probably not. Huh? Yeah, successful. So we'll set this aside and see what we read out of circuit. It's most assuredly going to be just completely open. Oh no, I'm getting all kinds of 500K versus 2 mega ohm versus 175K. Well, regardless, it's supposed to be 4 ohms. So, well, I don't know if it's supposed to be 4 ohms, but it's supposed to be, you know, almost 0. So, yeah, bad R402 for sure. And who knows what else. So I think what we'll do is I will go through and do the cap kit and the reflow. We know the thing turns on and powers up, so don't need to worry about the power supply. However, I'd like to be able to, you know, I think I'll do that. I think I'll take L100 out and make sure we're reading 117 and try to adjust it if we need to. I'll do that off camera. I've got 1,000 videos on that already. You just take L100 out, this guy right there, pop that side of the L100 out, hook your light bulb up to it, and you can adjust your B plus pot to reach 117 using the 60 watt, a 60 watt incandescent light bulb as an analog for the picture tube. And that's how you can set your B plus. I have a video, I'll link down below the light bulb test video. Now I think actually the test that I used in that video uses an LED, but for the method of how to test it and adjust it, that video will work fine. So I'll link that down below along with the video previous to this one on the channel that has the K7000 from hell that was just like this one. I'll link those down below. So I'll do that off camera, get the cap kit reflow and the light bulb test and the 117 dialed in off camera. And then we'll come back and we'll replace that resistor, test it out, and then I guess we'll try it again to see if our collapse is gone, and hopefully there won't be any other issues. Maybe, hopefully this will be a nice, quick, easy video. So I'll get all that work done, come back, and then we'll change that resistor and see how it goes from there. Okay, I lied real quick. I went through the parts pile here and I found a K7400, as you can see, has been picked clean with pretty much everything, but it does have the 3 parts that we need. The horizontal hold pot, the subcontrast pot, and most importantly, R402. Now, R402 is actually supposed to be like a 1.2 ohm, I believe it is. The other chassis on the other 7400, it read 4.0 on the other one, because I think there's other stuff in the components or on the chassis, other components that are influencing the reading. But because you're supposed to read resistors out of circuit, but with this thing here, with everything else out of it, the way that it is, R402 actually reads 1.3 ohms, so that's more likely close to what it's actually supposed to read. I'm too lazy to look it up in the manual, but obviously it's supposed to be, you know, a low ohm reading versus this other one that was what, 250K or some ridiculous number. 300. Every time I read it, it's different. So 348. So yeah, let's. I'm going to remove R402, the H-hold pot, and the subcontrast pot, and put them in this one that's all rusted. And then I'll go ahead and do the cap kit reflow and come back and we'll see how it operates at that point. I do also want to mention that this capacitor here, I think it's, I don't know which one it is, but this one, this cap here is bulging. I don't know if you can even tell or see, but yeah, I mean, you can feel it, that the top is bulging out, and it's, yeah, you can see. So bulging caps, as well as this probably could very well have contributed to this burning up. So, you know, yeah, when you have vertical collapse on these series of chassis, it's a very simple system. You've got R303, you have R303, D302 right under it, R402, D602, and the IC601 are really only the what is that, 5 components? 1, 2, 3, 4, 5. Yeah, it's really, relatively speaking, the only real 5 components that can keep the deflection from working on the vertical circuit. Now, the 26 volts comes from the flyback. It goes through R303, D302, through R402, through D602, and then through IC1. So again, like I say, if your 26 volt test pin is actually right here. So if you have 26 volts on this pin right there, but you have complete vertical collapse, it's very likely your IC is shorted. So you can actually test that by going to D602 in here, and if you test D602 in diode mode, it should read like a diode, a 0.5 voltage drop. Now if you swap the leads, it should read open. Boom, open. But if you get a 0.5 voltage drop in both directions, your IC is shorted. So if you have 26 volts on your reference pin and you have collapse still, you can check D602. If you read a voltage drop on both sides, the IC is your problem. So if you're missing 26 volts on your reference pin, it's only 4 things. It's only going to be DC. It's only going to be R402, R303, D302, or your flyback. It's really all that could keep that voltage from being missing. So anyway, just a quick tutorial there. So yeah, let me get the caps and the reflow and R402 and the pots replaced, and then we'll come back and see how it operates. All right, I lied again. I'm cutting in here because I'm going through here and doing the reflow, and I went ahead and also replaced the horizontal hold pot and the subcontrast pot. Here are the originals that are nice and rusty, and I'm glad I changed them out because, yeah, that's pretty bad. Both of these are not in good shape. So those have been replaced, along with R402 is now replaced as well. And just like the donor chassis we took it from, it does read correctly in circuit now. So 1.3, I don't know, there you go, 1.3. So making progress, but I'm cutting in here. I haven't done a cap kit or nothing yet, but I'm cutting in here because I'm started the reflow here. And I want to talk about, it's important to hit all of the pins, header pins for the remote adjustment board, your deflection board, and then these little 3 spots here for this transistor. They just like to get broken like you wouldn't believe. The pads lift off and the traces get broken, so that's something you want to hit too. But I'm cutting in here for one specific reason, is not just to talk about how it's important to get those all, and then of course the neck board header pins here for the interface connector. But I've mentioned before, when we first powered this up, I had to wiggle the connector for the power because it's absolutely, every one of these I've ever messed with, the solder joints on this connector are just very bad. And all 3 of them are cracked, all of them. Can I get closer here? No, piece of junk. If we can look at the right, there you go. You can see that one is cracked. And this one is cracked. And the ground is cracked. So you absolutely must, it's imperative to reflow those joints there. And then also your video input header pins, all of these are cracked. Let's see here. Red, come on, focus. Red is cracked, green is cracked, blue is cracked, maybe just the RGB, but the rest of these are pretty thin too. So the video input header pins, your power input header pins, this transistor, these pins for the pin cushion board. Did I say deflection before? I may have said pin cushion board, the header pins for your remote board, and the header pins for the neck board. All imperative points to hit. So I just wanted to point that out there real quick. Okay, so now for real, I'm gonna come back. I'll have everything done, and we'll test it out. And there we have it. All the work is done. I successfully got the cap kit done, the full reflow, including neck board, and actually had to completely reflow the remote board as well. It was dry. So basically every single, well, pretty much every single solder joint on this entire board was just not shiny and super thin and ready to crack at any moment. So I basically had to reflow the entire chassis. I had to reflow almost every pad on the whole thing. So I got reflow done on the neck interface connector, which we talked about before, remote board interconnect, pin cushion interconnect, this transistor, all of the video header pins, the power connector, all of the solder joints in the power supply section, all the solder joints in the horizontal output section. So basically every single joint that wasn't shiny, I had to reflow and make shiny again, because this was just in really bad shape. But there wasn't anything lifted or cracked other than the power input and the video header pins. Everything was, you know, right on the cusp of being bad. So I had to reflow pretty much the whole darn thing. So with that all being done, including the neck board, and I had to reflow the remote board as well, everything is looking good and ready to go. So this appears to be a very low hour 7500. Something must have happened to it, or it got put away or something before anything. I mean, there's not even the slightest hint at all of discoloration from heat from the neck board here. Now, of course, these have the later revision heat sinks, but I mean, there's not even a hint of discoloration at all. Like, this thing never ran hardly, you know, a couple of hours and got put away until I got it or something. It's just very interesting. So I did the light bulb test, and we were at 120 volts DC for the B+, so I set that to 117. I was able to successfully cut the glue off of there and move the pot to 117.5, so we're good on the B+. We'll have to adjust the shutdown pot if I can remember to do that and check that. Otherwise, I think we're ready to go. So let's get this on a tube and see if our collapse is done. And I realize now I forgot to mention that I did replace these. Did I mention it already? I can't recall. It's been too long. We'll have to. If I did talk about it already, then we'll talk about it again. But I did replace these rusted pots for the vertical or horizontal hold, I should say, and the subcontrast. So those have been changed out. And then we have our burned up R402. And then we have this capacitor here that was right there, the 2200 microfarad, which runs directly to the leg of D302, which goes across this yellow wire, which travels across through R402. So this capacitor being so far out of spec and bulging very well could be the likely contributor to our R402 going out and the collapse. So bad caps can cause other problems down the circuit. So we have this replaced, and again, I tried to show you before that the top is bulging up like that. You can feel it when you set it down on a flat surface. It wobbles around. See that? Wobble. So yeah, bad caps cause collapse. And other than that, I think, we know it operated and functioned. It just had collapse because of the R402 and the bad cap. So after their complete overhaul and refresh, let's hook it up to a tube and see what it does. Actually, before we do that, I forgot to mention that I did remove this little redundant width transistor, because this frame has the frame mounted transistor. So I'm still mystified as to why there was a redundant one here. This may not be the original chassis to this tube, but regardless, I took it off, put it in the spare parts bin, so now we have an extra one of those. And yeah, I just wanted to mention that in case you saw it, like, hey, what happened to it? Well, I took it off. So okay, let's get it on the tube and see what happens. Okay, so everything is hooked up, ready to go. Back on the tube, we got our anode neck, yoke round power video remote, the Critical 7. I also have the TPG for the video. The TPG is connected because I don't want to blow up a PCB if something goes haywire. I did get all the color pots sprayed with some deoxit and wiped back and forth to get those cleaned up, along with the same treatment on the remote board pots, and got all the color pots set to about a quarter intensity, because anything higher than about a quarter turn from zero, the colors begin to bleed on the contrast. So about a quarter turn on these is where you want to put those as a good baseline. And then the drive pots you put at 50%. So that's where those are set. Everything is secure in the frame. I did clean this bottom plate as best as I could before putting this back on, so that's all done as well off camera. Our width transistor is connected. We have our meter set up to read B+ to make sure it's at 117, and it connects right to the test point right there by that capacitor. And the ground can just go right to the frame. So everything's ready to go. Right now we're just concerned on whether or not our collapse is resolved. The yoke is not only has a bunch of surface rust on it, but it's also loose, but not that big a deal, because we can just take the the stopper here, whatever you want to call it, the standoff or the wedge, and just shove it down a little bit further to compensate for that. But the main goal here is we're going to have to get all of the convergence reset here. So none of the rings actually moved, it's just the entire assembly. So once we find the sweet spot to make the convergence good, it should, hypothetically be good, and we can just epoxy it in place. What I like to use is this black high temp RTV. It's just high temp RTV that you can use like a gasket maker for an engine in a car. So it resists the high temperature of the heater. So we can just apply this to the top of the ring set and then the glass part of the tube itself. And then once it dries, you'll never have to worry about that coming loose again. So that's what we're going to use if we end up needing to. All right, so assuming this all works, I'm going to actually put the camera on the tripod for the convergence part of this, as opposed to the handheld, so we can get a good idea of what's going on. And other than that, I think we're ready. So after all that work, let's see what happens here. Turn that on. Okay, 1, 2, 3. It's slow to energize. Oh, crap. Well, we still have... Oh, hang on. We've got smoke. Oh, wait a minute. R402 is nice and toasty again. My brand new R402 is nice and toasty again. And that's why I don't run the fan when I do this. Is it hot? It's going to have to be hot. Well, not really. A cap didn't burst. So it wasn't that. It's definitely discolored from how it was. But we still have collapse, and now 402 is toasty again. It didn't, I'm pretty sure it wasn't on long enough to have it get taken out again. So now we got to figure out what is causing R402 to burn up. I think we checked D602 and that wasn't shorted, so I don't think the IC1 is bad. Something else is still faulty and taking out... Oh, you know what? Let me try something here. Let's disconnect from the test point on the B+ and go to our 26 volt test point and see what our 26 volts is saying. Real quick here. Okay, 3.6 volts on the 26 volt reference. So something is still faulty. Could it be the flyback? I don't know. I never tested D302 or R303. Let's test those real quick and see what comes up with that. Okay, so I suppose it's my fault for not checking R303 and D302, but looking at R303, it is a bit charred here. And not only that, if we read it, it's supposed to be 1.2 ohms, if I recall correctly, and it reads 6.6, so that's not good. But that shouldn't be enough to cause it to collapse completely. But that could be a contributing factor, so we're going to have to yank this guy out of here. Oh, I didn't turn my iron on. Give me a second here and I'll cut away and come back when the iron's hot. Okay, iron's hot, so we got to grab that one and that one. Okay. So that's out. Does it still read 6 ohms out of circuit? Yeah, 6.7. That's not good. So that's out of spec. D302. Let's make sure it's good. Yep, it's not shorted. 441, and let's read it the opposite way. And open. So that's fine. So we're going to have to grab another R303, and it's possible Q801 is faulty because R402 travels directly to the base of Q801. If we look here, we can travel this through here. So R402 goes across that jumper and right to the base of Q801. So let's check Q801 and see if it reads funky. Brass transistor, that funky transistor. All right. I'm not sure how you read this one. It could be PNP or NPN, I don't know. 0.6 and 0.6, so it's not shorted. Let's grab this donor 7400 that I was getting parts off of, and let's test this one. And it looks like R303 has already been pillaged out of this one, but I can find a 2 watt. I think this is 2 watt, 3 watt, could be 3 watt. I can find that resistor anywhere. So let's do Q801 on here. So we had rated lead on the base, and then it was 0.6 to emitter and collector. So 0.6 and oh, hang on. 0.6 and 0.6, so it's not Q801. That seems to be okay. Let's just check and see if let's see what we get as far as readings on our vertical IC, just to make sure no pins read odd to ground that shouldn't. So if we go to ground, and we go to ohms, we should only have one pin that reads to ground, and I believe it's this one. Yes, 0.1. So if we just go, I think pin 1. Well, now wait a minute. That's not right. That's dead short to ground. That's dead short to ground. We should not have 2 pins going to ground on the vertical IC. So something is shorted. So now, for example here, if I go to this very first pin and go to ground, that's dead short to ground, 0 ohms. So for comparison, if I go to grab for testing purposes, this 7400 is going to be the same thing. So if we take this 7400 and we go to ground on that first pin, open. Oh, you can't see. I'm an idiot, sorry. So, nothing. So pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, pin 5, I don't know if it's 5, it's 6 from the opposite way. 1, 2, 3, 4. No, it's, yeah, pin 5 from this way, 6 from this way. But, as I said before, you should only have one pin going to ground on the IC. And this first pin here on this one does not. But on our other one, it does. So we've got a dead short on something on that line, and that is what is burning up R402. So let's try and figure it out. Let's grab a resistor, replace R303. I said I could find one of those anywhere, and you know, they're all over the chassis. So if we go up here to the power supply section, you can see that even up here in the power supply section, we've got one right here that reads that's 0.4. That's a bit low. I think one of these is 1 point. There we go. Perfect. 1.3. So yeah, there's these 1.3. I think this one's 1.3 also. No, that's 18K. Yeah, maybe this one is 1.3. There's a couple of them that are 1.3. 5.2K. That's not right. Hang on. Maybe it is. I don't know. I know that there's a couple of them on the board. So we'll steal this one for R103 or 303. Sorry, R303. We'll steal this one. And we'll plunk that in that spot. That's why it's handy to have these parts chassis. Somebody commented on the previous video, what does it take for a chassis to become a parts chassis? When do you give up on it? Well, I don't really give up unless there's a part that can't be acquired. So let's say you got a K7500 and the flyback is bad and you can't get one of those, so then it becomes a parts chassis. I think ever since I started making videos, I've been beaten by chassis before I started getting experience and knowledge. But I'll say that I've never had a chassis on the channel or a video or a chassis that I've have sent in by somebody to have fixed or whatever that has ever defeated me. So I've never had one that's become a parts chassis because I couldn't fix it. Usually the parts chassis are something that I'll find on eBay or something that someone will donate to me. Like this giant closet of spare parts that I have over here off camera, all these spare parts chassis, because over the years someone has either sent me one, hey, I got this parts chassis, would you be interested? Or I'll buy something on eBay because I want to get a couple of parts chassis to steal parts from that, you know, they'll have otherwise, you know, be burned up or have already been picked clean or things like that. So you know, every so often I'll get a chassis off eBay just for a project to get working. You know, if I need a 7500 and I don't have one, I will go online and find one. And of course, it fell down there. Talking and doing this at the same time is not a strong suit that I have. It's not my strong suit. I need to go to the Men's Warehouse and get a stronger suit because this is not my strong suit. Putting components in while not talking appears to also not be my strong suit. All right, there we go. I know you can't see, but bear with me here, sorry. All right, so R303 is now replaced. It doesn't want to go in there because it's got... There we go. All right, now don't fight me on this one, eh? No, I'm not going to join a cult. I can't believe you're pulling this shit on me after Monday night. We wanted to watch your show, and I did that for you. Yeah, you kept flipping back to the game. I wanted to see the freaking score. What do you got to do that's so freaking important you can't join the religious cult with me? The night time is the right time. The night time is the right time. You're not mad at them making you kill your father, are you? You know, it's like they said. It was the only way to save him. You're a good friend. You're a better one. If you know what that's from, I give you a tip of the hat. If you know what that's from, I'll give you a tip of the hat. Okay, let's go to ohms, and we get 1.3. R402 still reads 1.3. I know you can't probably see that, but there you go. So Q801 was fine. So we need to either extract. Here's the easiest way to find out what's shorted. So is it the vertical IC or is it something else? The easiest way to do this is to just desolder the pin from the circuit. We'll desolder this pin from the circuit, make sure it's not touching, and then see if it still reads to ground. Okay, so now if we touch the pad to the pin, we have no continuity from the pad to the pin. If I push on the pin, continuity let go. Okay, so we have no continuity to the pin. So if we go to ground and we touch the pad, no short. If we touch the pin itself, short. Vertical IC is bad. Now, what's odd about that is normally, like I said, the easiest way to tell if your vertical IC is shorted is to just go to D601, and it should be good. I thought we had done that. So D601 is down in here, and yeah, 0.598. Now, if we flip the leads, it should be open, and it is. So I guess we've both learned today that even though D601 does not read shorted, you can still have a shorted vertical IC. You know, these things are just in my darn way. I'm gonna take this neck board disconnect it because it just keeps getting in my way here. And we need to lift this, and this folds right out. Okay. Okay, now that's a lot better. All right, so, okay, vertical IC, no good. Let's remove it and put a new one in. Shouldn't be too difficult. Yeah. This is one of the things I did in Reflow because I didn't need it, so there's not much solder on the joints. It's easier to desolder using this braid if there's more surface area for the heat to flow and transfer. So sometimes if you're trying to use this braid and it's real stubborn on you, add a little bit more solder to the joint, and then it should end up working just fine. So. And sometimes if you want to go back over and use a piece that already has solder still in the wick or in the braid, that will help also. And I can hear you saying, why don't you just use the hot air, or the, not the hot air station, what the hell is that stupid piece of crap called? Desoldering station? Because it's, the one I have is a piece of junk, and it clogs after one use, and I don't like having to unclog it after each pad that I suck out, so nope, I just use the braid. It's just easier and less of a headache, and I don't got to worry about cleaning the stupid thing. It's just a nightmare. So all right, I got to add more solder to this one. Okay. Nothing's ever easy. Where is my screwdriver? I can't find it. Oh, there it is. You guys tried to hide it from me. Why did you do that? Well, actually, technically, I guess you did successfully hide it from me, but... And does it easily just come right out? Yep, voila. Now we can check this to see if that pin is in fact shorted. Which one of these is ground? There's ground. So here's ground. Here's our in pin. Dead short. Dead short. 0 ohms to ground. All right, well, do I have a replacement? I think I do have a couple of brand new ones. Yes, 2 brand new ones. Boom, okay. So, that being said, we'll test the brand new one, make sure it's not shorted. So, there's our... So of course, I will reiterate here that a lot of counterfeit parts are floating around out there. If you get one of these and you go 1, 2, 3, 4, 5, there's your ground wire. There's your ground. If you got a ground on pin 6, then you have a counterfeit vertical IC because the ground's supposed to be pin 5. There's a whole bunch of these floating around out there that are counterfeit that have the ground on pin 6. So the ultimate test here is to go to pin 1 and we have no short. So let me put this in. We'll solder it in place and then we'll test it again. That went right in there, okay. Try and get this guy in there as easily. Nope. Failed. Nope. Failed. Okay. Hey, goat! Huh? It's dark, I cannot see you. Come closer. Hello? Oh, hi, what's the good word there? All right. Let's get this back in here. And sometimes this can get tricky trying to not create bridges. So we do this from the side and we go down the line towards the pads that don't have solder on them. And it's just the easiest way to not create bridges. Perfect. Let's clean it up. And they have a successful vertical IC replacement. Let's make sure we don't have any shorts to ground. So we go to ground and we got pin 1, 2, 1, 2, 3, 4, 5. Pin 1, nothing. Pin 2, nothing. Pin 3, 4, 5, 6. Okay, so pin 1 is this side over here, and it's actually labeled on the board as 1, but not sure if you can see right there it says 1. So 1's actually to the right, so we'll go back the proper way then here. So 1, no short, so we're already fixed. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Darn it. So let's hook our neck board back up. Got our G2 wire and our focus wire. Pop it back in, get our connection back on. All right, well, let's hook it back up and do, I guess, technically it's take 3, because the first time we turned it on to discover collapse, that was take 1. Previous was take 2, so here we go, take 3. Hopefully third time's a charm, and we'll see what we get. Okay, we're all set and ready for take 3. This time I have, turn that on, this time I have the meter set up to read our 26 volts AC. I said it again. 26 volts DC. Why do I keep saying that? I work on airplanes, and some of the airplanes I work on have a 26 volt AC reference for heading computers and things, and for some reason it just translates over to this. So anyway, 26 volts DC. So when we turn this on, we should at least know immediately if we still have our 3 volts in our short, or if we get our proper 26 volts. If we do, then we should have complete, can't see, complete deflection, hopefully. So anyway, yeah, if it does work, then I'll move it over to the B+. We'll make sure B+ is around 117, and then adjust as needed and do what we have to do from that point. So here we go, fingers crossed. Attempt number 3, 1, 2, 3. Yes, 25 volts, close enough. And how about that? Okay. Hang on 1 second. All right, sorry about that. I had to take care of something real quick. Okay, so we have 25 volts, give or take, close enough to the 26, which is actually, it's supposed to be 26, but 25 is actually about the normal. So, and it's working. We're shifted way over to the left, and our contrast is way too high, but we have deflection. That's the important part. Nothing is burning up or smoking that I can detect. So let's move over to our B+ test point, which is right here. The official test point right there, and we get 116.8. Close enough not to mess with. Okay, so now I'm going to set up the camera and on the tripod, and what I'm going to do is I'm going to move this all around, and as you can see, as I move this thing around like this, we have the convergence moves all around. So it's going to be about finding the happy point. Once I find the happy point, then I'll get the camera off the overhead and we'll try and RTV this in place and get that going. So let me get the camera on the tripod to get a little bit more professionalism out of this, and we'll kind of go from there. All right, so first things first here, I'm going to get rid of the meter here so it's not in our way. I don't want wires getting tangled up and accidentally causing some type of damage, so okay, now let's adjust our contrast down, H position over. That looks good. Vertical position is right there, height right there, width right there. Okay, I'll say brightness needs to be about, that's not enough, so let's turn our flyback down. Okay, brightness up and then to about right there. Sharpness right there looks pretty good. Okay, so now let's move over to our convergence. Oh, we got, wow. All right, well, let me show you guys my manual degauss method. So you can see we are terribly gouged up right there. I don't have my wand, it's at the arcade, so let's do a manual degaussing. So I've got this pinball computer speaker here. It's just a standard pinball computer speaker, and you can see how it affects the image here. So you have to be, I'm going to say right now, disclaimer, never ever do this. Do not do what I'm about to do. Under any circumstance, never do it. Because you can damage the shadow mask if you use a magnet that's too powerful. Never do this. That being said, I can take this magnet here and kind of wash away the yeah. Sometimes it takes a little finesse. So if you hold it like this, it causes the green. If you turn it around and hold it like this, it causes the blue. So the magnetic field affects what you get out of this. And I mean, that's pretty good. It's still bad here and it's still bad up there, but a few power cycles can fix that. A few power cycles of the monitor. There you go. I mean, sometimes, I mean, it's not perfect. There's still a little here and a little dark over there. But, I mean, if we scroll through, there's the red screen. Yeah, I don't like that over there. And you can make it worse trying to perfect it. You can make it a lot worse. It doesn't have to be perfect just for testing purposes, but anyway. So, close enough. All right. Just, I don't think I've ever shown that on the channel, so. Okay. Now, we got a little pin cushion action going on. So, this did not come with a pin cushion board, but I just, by pure happenstance, happen to have one. So I'm going to plug this in here. I have to kind of move this out of the way. And I'm going to turn this off so I can reach in here and try and plug this board in. Okay, plugged in. Make sure it's in there properly. Appears to be. Stuff in the way. Hang on, you piece of junk. There we go. All right. Now, let's see what we get now. A little better. Okay. Probably could tweak those pots slightly, but That's a little better. Anyway, okay. So how do we show this here? It's really not bad right now. I'd say, nah. Right about there. Right about there is pretty good. So let me zoom in a bit. You can see here that just moving those. So what benefits us is the fact that the rings themselves aren't individually moved. They're still where they were. It's the entire assembly moved. So that benefits us in the fact that all we got to do is just find the sweet spot with the ring assembly. Then I'm going to grab this and just kind of glue it in place, but I'll take it back off the tripod here so we can witness how I do that. And of course, turning your contrast down slightly and brightness up, it looks pretty good. So I'm happy with that. So the next step here is if we move the yoke a bit, yeah, I'm going to need to shove that down in there. Perfect. Okay. I'll have to remember to tape that back in place. So I just took that top little stopper I mentioned before and pushed it down a little bit more, and that angled the yoke back slightly, and that fixed it and made it a little bit more perfect. So if we come in here, you can see that it's pretty much perfect for the most part. Nothing too dramatic, everything lined up, all the dots are good, corners all around. So I'm happy with that, nothing out of whack. So now we need to simply get that RTV installed and hook up a real PCB. Let's see what kind of image we get, and we can call this repaired. So actually, let me see if I can do this in a way that you can watch this. That makes the most sense here. I'm not really going to be able to do it with the tripod. Well, maybe if I come over this way. Sorry, this is the amateur channel, not a professional. Is that going to stay on there? Probably not. I lost the little adapter that keeps the camera on the tripod, so I don't think it's going to stay. Hey, there we go. Stay there, you. Don't fall, please. Okay. So we can simply, you know what, let's turn this off and remove the neck board. Okay, and we will apply some of this liberally on here. And then after we get it on here, we'll turn it back on and set it back in place. Clean the edge of this off. Right where it should be. Kind of smash it down. You really only have to worry about, I realize it's moving all over the place again, but that's fine. Just set it something like that so where it's in place where it should be. Then we can turn it back on and, well, as expected, I hit the I hit the tripod, camera fell off. Okay, well, I mean, as you can see here, I've just kind of liberally applied it all over that, and once that dries, that's not going to move on you. So, and it takes a while for it to dry, so we're not in any danger of having to hurry here. So we'll get that back on. Now let's turn it back on, and it's still going to be on this, and we'll let it turn on here, and actually it's still pretty good. I may need to tweak it slightly. I say, nah, that bottom corner I need to. Okay, yeah, I think that's pretty good. So, yeah. This is more of a, actually, let me see if moving this will fix that. Oh, there we go. That's good. Right there. I think that should do just fine. That'll do, pig, that'll do. Okay, now we need to get a real PCB hooked up. Let's do Cruising USA. Get UMK3 out of here. And we'll grab Cruising USA. And gonna have to turn it off. Plug this in. Okay, and disconnect this. Turn that off. Connect this and turn it back on. And now that we have that in place and RTV'd in spot, we can take a look at this, and yeah, that's pretty good. Convergence is good. Check that out. Convergence is pretty good. Okay, let's get you back on the tripod here. Hang on. And we'll make some adjustments. Now, this should stay now because I'm not going to bump into it. All right. Colors look close, but not perfect. Let's do H position. Width is good. Yep, width is good. Vertical position, right there. Let's do height. All right, so we're good to go on that. Let's do a little bit more contrast. Ah, that is looking good. Let's do some focus right about there. Well, notice here how perfect this looks, and I didn't even touch the color pots. So, like I said, a good starting position for a good baseline for color adjustment on all the color pots. On the main bias pots, put those about a quarter turn up, and the drive pots about 50% halfway up, and you know, that's a good baseline, and that's where we're set, and the colors look beautiful. So monitor works, yoke is good, chassis repaired, the yoke, or the convergence rings are now set in place. About, I don't know, 12 hours from now, that RTV will harden, and it won't be susceptible to the heat from the neck, and it should keep those from coming loose ever again. And of course, a little alcohol on there will loosen it up, so if you have to take the rings off in the future to change the yoke, the little alcohol on there will soften them up, and you can get those off of there. So it's not a permanent solution, it's just a solution that keeps them from moving unless you want to take them off. So, well, there you have it. I don't know what else to say. Turned out great. We had, let's see. Let's get all these front and center here. All told, we had a capacitor bulging and most likely bad, which might have cascade failured everything else, because R303 is connected directly to this cap, and this cap was bulging, so I assume that cap went out, which brought this out of tolerance, which then took this out of tolerance, R402, which then shorted the vertical IC, and these are just rusted. They weren't necessarily bad. So 4 bad components. Now, I don't know if the cascade failure happened from the cap towards the IC, or the IC shorted and went back and went the other direction. I don't know. But regardless, 4 bad components in the vertical IC section, vertical output section, and after changing all those and doing all the rest of the work on the chassis, we are good. Oh, I ran into my step stool back here. I don't have enough room, sorry. But there you go. Fantastic. Another monitor resurrected. I'll add this to the collection, and Otherwise, I appreciate it. As always, like, share, and subscribe. Thank you very much. Stay tuned for more, and we'll see you then.